video, we're going to be we're going to be driving the general form of the ellipse and finding out how to calculate where the focal point is, or the focus. So let's get a picture here and take a look at the definition again. So if I got my picture, and we're just going to use a parabola going through the origin. We can look at when it goes through it, when it changes, it goes to a different value in a later video, but for right now we're just going to take the basic case when it goes through the origin. Now I am going to let it be a general case when it goes to the origin, so I'm going to find y to be ax squared. Now I'm going to notice that if I were to use a bx and plus c, well, what that's going to do is it's going to change my center, and I can show that by doing the complete the square like we did in the first video. So the main case that we're really worried about is what does this a do, and what's important about that a. So I'm going to let this be a general parabola that goes to the origin. And let's say that it looks like this. So if it's going to be a general parabola that goes to the origin, gotta look like this. Now notice that if I put in 0 for x, I'm going to get back 0 for y. So my vertex here is going to be 0, 0. Now, the distance from your vertex to your focus is defined as p. So if I move up p, and this is x and this is y, if I move up that p distance, well, the y value is going to be changing by p. So this value here is going to be 0p. And then down here, and directrix is a line, not a point. So if I move down here, this would be the point 0, comma, negative p. Now p is defined to be positive because it's the distance from the vertex to the foci. Now I can also say that it's the distance from the vertex to the directrix, but it's a distance, and distance is always positive. But if I'm moving down, I can say that it's going to be negative p because I'm moving a positive distance in the positive units in the negative direction. So it would make sense to say that this is negative p, and here's my directrix. Now, we're looking at the vertex. The vertex is always right between the foci and the directrix. That's an important concept. So if I find one distance, I can find the other distance pretty easily. It's always going to be adding that distance to from both sides to find my foci. Now, I'm going to find the general equation of this. I want to see if I can find what this p value is. And based on the definition of parabola, I can pick any point, let's say this point right here, and I'm going to call this xy. Well, we know that the distance from here to here has got to be equal to the distance from here to here. My picture is not perfect. It looks like the long one's longer, but that just means my parabola is off a little bit. Because a parabola is defined as the set of all points of equal distance to a point and a line. So I'm going to find out what this distance is, and I'm going to find out what this distance is, and these two things are the same. And to do this, I'm going to use the distance formula. And just as a reminder, the distance formula is a direct application of the Pythagorean theorem, but I will throw it up on the screen here. It's going to be d is equal to delta x squared plus delta y squared. Delta being the change in. So it's going to be change in x and change in y. So if I'm going from this distance to this distance, well, it's going to be the square root of x minus 0 complete square plus y minus p complete square. That's going to be the distance from here to here. So my first term minus my first term, second term minus my second term. And that's going to be the same distance as the distance from this point to this point. Now, a good question to ask right now is, what is that point? Well, this blue line is actually the equation y is equal to negative p. So if I have that negative p there, any point on that line is going to be negative p. Now, the x value is changing, the y value is not. But if this is x, and I drop it straight down, this also has to be x. So this point right here is actually just going to be x minus p. So then this distance from here to here is going to be the change in x, which there is no change in x because I'm dropping it straight down. Stick with red, apologize about that. So if I drop it straight down, what we're going to have is the square root of x minus x complete square. And then what I'm going? I'm going from y to negative p. So it's going to be plus y minus p complete square. And these two things, minus p. So it's going to be y, because this is a negative p, so I should have y minus negative p right here, complete square. And these two things have to be equal. Now that y minus negative p is actually a y plus p. So let me rewrite this. And x minus 0, that's just x. So this is going to be the square root of x minus 0 is going to be x squared plus y minus p squared is equal to the square root. Now x minus x is actually just 0. So let me get rid of this, because x minus x, that would be 0 squared. 0 squared is 0. So I can just write this as y plus p complete square. And now I'm down to this. And I have the square root of something is equal to the square root of something. Now, all of these are defined to be positive distance. In this case, x here is actually going to be negative. That's going to be my only negative value. But it's going to be a negative value squared. So all of my values under the square root are going to be positive values, since every term under there is being squared. So I'm actually not going to run into the case of having a negative. So I can square both of these without loss of generality. And I don't have to worry about that negative case or imaginary numbers, because all of these are going to work out nicely. But just a comment that we should say, we can't just say that in general usually, but in this case, since everything's squared, it will work out very nicely, and I don't have to worry about loss of generality. So I can just square both sides. So if I square both sides, both of these square roots are going to cancel out. So this is going to be x squared plus y minus p quantity squared is equal to y plus p quantity squared. And I'm going to FOIL both of these. So we're going to get x squared plus y squared minus 2py plus p squared is equal to y squared plus 2py plus p squared. Now nice things happen. I've got a y squared on both sides, gone. And I've got a p squared on both sides, gone. And then I'm left with an x squared over here minus 2py is equal to 2py. Well, what if I solve this for x squared? So I'd get x squared is equal to 4py by adding the 2p over there. Well, my original, what I started with, was y is equal to ax squared. Now, that distance there, that p, that p is going to be the distance from my vertex to my foci. Well, if I know that y is equal to ax squared, how about I put this in terms of y so that I can get a meaningful value of that x? So what we're going to have here is I'm going to write this as 4py is equal to x squared, just swapping the sides, putting this side over there, that side over there. And let's divide by 4p. So that's going to give me y is equal to 1 over 4p x squared. Now what we know here is the distance from the vertex to the foci, or the directrix, both of them, is going to be p, but isn't this the value in front of x squared? Isn't this the value in front of the x squared? That means in any equation, if I want to get the foci, the distance from the vertex to the foci, I know that a is equal to 1 over 4p. That's what I got from here. So if I'm given any equation, I can just take that a is equal to 1 over 4p and find that p very easily. Let's do a quick example. So if I'm looking at the equation x squared, y is equal to x squared, what is my a value? Well, my a value right here is 1. We wouldn't write it like that generally, but that's my a value. And I know that a is equal to 1 over 4p. So I can say that 1 is equal to 1 over 4p. Well, if that's true, that means that p is equal to 1 over 4. P is going to be my distance from my vertex to my focus. So if my vertex is right here, that distance to my focal point is going to be 1/4. So in this parabola right there, I'd be moving up 1/4 from 0. So this would be the point 0, 1/4. And then I'd be moving down 1/4 down here to get my directrix. Well, the directrix is a line, so this would actually be the line y is equal to 1/4. All right, so that is one quick example. We would do many, many more in the next video. See you guys next time.